Hello friends, welcome to my channel DataMaking. Please subscribe to my channel to get more technology videos. Okay, this is the next video in my Apache Spark project video series where we are building a stream processing application. Okay, so in the stream processing application, so basically we build the architecture like we take the stream data from the meetup.com, which is meetup.com actually provides a public data set as a stream API on their platform, meetup.com platform. Different groups host their events, right, or meetups. So when they put the event details, so people actually from that group they go and say the RSVP, whether please reply message. So they'll say whether I want to come to that meeting or I'm not coming to the meeting, or maybe I come. So basically, there's three possibilities. One is yes for if they are going to attend, or no for they're not going to attend, and then maybe they provide the other scenarios maybe. So those RSVP data, the Meetup.com actually publishing or exposing to the outside world as a streaming API, the REST stream API, which is the REST API. So we are actually consuming the REST data, API data, the stream data, and we are actually writing a Kafka producer to publish the data into Kafka broker, which is in Kafka topic. So then we are actually now we want to consume the data. In the last video, we published the RSVP data from meetup.com. We consumed it and we wrote the Kafka producer to publish to Kafka topic. Now we actually going to write the Spark structure streaming program and write into the consume the data and do the processing. And we'll write the process data into MySQL database and the raw data into MongoDB, NoSQL data store. Okay. So before going to the topic, let me minimize the recording window, and also I will give you the quick walkthrough of what is Spark structure streaming. So when the Spark community has developed the Spark framework, so initially they developed a core APIs, which is RDD, and then they introduced slowly data frame, and then machine learning APIs and Spark SQL. Okay, so then there is a additional library they added called Spark Streaming, which is for real-time stream processing. So initially, when before Spark 2.x, they were using the traditional Spark streaming, which is RDD based. So you get D stream, which is D stream based. Sorry, the traditional Spark streaming is based on the D stream, discretized stream, which is actually wrapper over your RDD. Okay. Now in the Spark 2.x 2.0 from 2.0, they introduced a new API for streaming, which is Spark structure streaming. So whenever the stream data comes, it comes as a data frame. Okay, so it's kind of tabular data which is coming. So they call it as the unbounded table. Okay. So if you see this diagram, okay, so the data is coming in a stream as a stream, but you see this, you can think this as each record you can think as a table row. Okay, so streams each stream data or stream record you can think as a table row. So this is an unbounded table which keeps getting appended. So either you can actually take entire unbounded table, you can do operation, or you can take only the latest inserted data, or you can say inserted with updated data. Okay, there are three modes available where you can actually take the data and process. Okay, so if you look at here, so at the time interval, so every 1 second they are actually triggering. So you can say it's a batch interval. So every batch like t, the time interval t equals to 1. So you get this result. Okay. On the time interval 2, you can actually the data is grown, right? This is the input is getting. Okay, so you are processing. Okay, and then the so in the time d3, this sorry, t equal to 3, you see this data is grown up. You can do the some kind of calculation, you get the result. So basically, so in this is output mode for complete. So in the complete mode, you will have all the, you can basically do the all the kind of aggregation on this data set. Okay, so so there are three modes available, which is complete and append and update. So actually, I did a detailed videos on this Spark success streaming. Please go through my video. So it will be given the full details. Okay. So this is all about Spark success streaming. So basically, it's a data frame based operation. You can do it on the for the stream processing. Okay. So that's what we developed here. Okay. So basically, what we did is this is a SPT based Scala project. So if you see, so if you this is, I'm using a IntelliJ IDE, which is integrated development environment. Basically, it is used for developing Scala based project and also Java based project. Okay, so you can write a Maven based project as well as SPT based project. SPT is a build tool. Okay, so it's a simple build tool or Scala build tool, you can call it as. So so basically, so what I'm did is I just created a project called Meetup.com RSVP stream processing as a project name. So this is the structure. So you will have a source folder and you will have a target folder. Once the on the source code is all your Scala code will be here. Once the Scala code, once you build this jar file, the jar will go to the target folder. So all your dependencies basically you provided in the build.spt. Like if you are familiar with the Maven projects, in Maven you will have pom.xml, right? Similarly, in the SPT based project, you will have file called build.spt, which will actually a place where you can provide the dependencies. So I'm going to use the so all your in Spark 2.x, so you provide the dependencies org apache .spark and the group this is the artifact ID. Okay, so artifact ID is basically Spark-SQL is a group ID. Okay, so so for I'm using Kafka to consume the message from Kafka, right? So I'm using Kafka integration. So I need to provide the dependency for Kafka. So you need to provide two dependency. One is for Spark Kafka and Spark clients too. And the third one is I'm going to use a MySQL for storing the aggregated data. So I have to use the MySQL connector, and also I'm using MongoDB for storing the raw data. Okay, so I need to use the MongoDB Spark connector. So all these dependencies you can actually take it from the Maven repository. So all this dependency details, and you can put it here. So once you go to this project, okay, and if you try to refresh, okay, refresh all SBD project, it will just go under get the build repositories and it will build it. Okay, this is how you can actually build the project, or you can go to the build directory build project you can do. Okay, so this is how you can actually create a Spark structure streaming project using a Maven based Scala. Okay, now what we need to do is basically you need to import the required classes. So for Spark SQL, all this in Spark 2.x everything is wrapped. Okay, so you need to create basically all your in traditional Spark streaming. You need to create a Spark context and then create a streaming context using a Spark context, and then you can actually consume the basically you can consume the message from different data sources using the different connectors, right? So in Spark structure streaming, everything is wrapped into the Spark SQL. So import the Spark SQL package and also types and functions and the streaming.trigger, which I'm going to use for batch interval. All these packages you can import it, classes packages. Now this is the Scala object I created. So in Scala you can create an object or a class, Scala object or Scala class. Scala object basically a singleton where you don't need to create an object for it. So you can just directly write a main method and you can write your code. If you're writing a Scala code, you need to create an object and then execute your program. Okay. So so then once create a Scala object, I have a main method. Okay, in the main method, it takes the arguments. Like if you are aware of Java program, then it's like public void main function. Okay, so then you initialize all this variable. So what I think I'm doing is basically just initially I'm putting some print statement here. Sparks processing, stream processing application started. So these two are for Kafka. So I'm going to consume the message from Meetup RSVP topic, and then I'm going to basically basically invoke this message, right? So what is this message is basically uh, for message we are going to consume it from here, and then the Kafka topic, right? So Kafka topic is we are interested is Meetup RSVP topic, and the Kafka bootstrap server or Kafka server is localhost colon 9092. So this is the our Kafka environment. Okay, so I'm using local only. So if you are actually if you are trying to use a remote Kafka server, then you can provide the IP address and the port number. Then this is the MySQL details. Okay, so we'll talk MySQL details about later. So so basically it has MySQL database connection and table and what is the driver, other stuff. So this is where we need to see the MongoDB details. So I'm using a MongoDB local instance. Okay, so this is the MongoDB campus, which is a GUI for your MongoDB database. Okay, so this is where I have RSVP is RSVP meetup underscore RSVP underscore database underscore DB is a database in the MongoDB, and I have a collection called meetup RSVP message detail underscore TBL. In this collection only, collection is nothing but a similar like table in RDBMS. So we are going to publish the messages into this database. Okay, I'm just refreshing my collection. Okay. So I don't have the collection, so basically I deleted, I guess. So let me create and I'll show you. So now what we are going to do is this is the collection. Okay, let me create the collection. This is the collection. You can go here, create collection. MongoDB, if you want to know how to install MongoDB on Windows machine, I prepared a video series video on this. Please check the environment setup video. I will actually explain you how to access it. Now we created the collection. So this is the database, meetup underscore RSVP underscore DB, user ID password, and so this is the basically the collection we are going to push the raw data. So first thing is you need to create a Spark session object. So Spark session object is the entry point or a kind of connection you make to the connection object it used to for connecting your Spark cluster to run your the Spark code. Okay, streaming being a streaming application or batch API application, you need to create a Spark session object to submit your code into the Spark cluster. So I'm creating a Spark session object. So you can build using a builder method dot provide the master URL and then application name and just dot get or create, which will give you the Spark session object. So you can set the log level into different, like either if you want info log also, you can just ignore this line of code. So I want to just see only the actual messages or actual output. So I just ignore the info message. You just set the only error log you want to show, like that. Now, so this is a very important piece of line where it says you are going to actually read the stream data. Okay, that's what it says. Spark session object dot read stream, from where what is your source. You're going to see, you're saying that from Kafka, the format is a Kafka. Okay, so you need to provide the Kafka server details, which is a bootstrap server, which is Kafka server, and from where you are going to subscribe it. So from topic, what topic? I'm going to subscribe from the topic called meetup RSVP underscore, sorry, not sales, this is the Kafka topic which I'm going to consume it. Okay, Meetup RSVP topic. So once that details is provided, so I'm going to read the latest messages from the topic, not the old messages. So I just given the starting offsets as latest. Okay, so on dot load, what this will do is it will continuously go and read the messages from the Kafka topic. Okay, so how much interval it will go and read, I will tell you in the below lines of code where we set the batch interval, which is a trigger interval in structure streaming. In traditional Spark streaming, it is called a batch interval. Here it is trigger interval. Okay, so this is the data frame you get once you read it. So that data frame is just, I'm trying to see the schema of that data frame. It will just show what is the column there. It will have a key value, timestamp, offset. There are different columns by default. So we want actually, so I told you in the, when you publish the result, when you publish the message to the Kafka topic, we publish key and value. Key will be topic and value will be the entire message, right? So we want to read that value column and parse our JSON. So I told you the JSON structure is like this. Okay, so this is the complex or not complex, basically it's a nested. It is somewhat easy only. So basically this is the nested JSON structure. Based on your JSON structure, you form the schema. So basically, so that you can actually pass the data easily. Okay, so the struct type is basically says that your the JSON object structure. Okay, so it's a complex object, and then it will have a okay column called field called venue. Okay, you need to provide the, when you have a struct type, it will have array, then followed by struct field. So the struct field in the field we are going to mention. So the first field is a venue. Venue as a complex object, which is again on more JSON. So that's why we introduced a struct type, which again has array, and you need to provide other fields. So venue has three subfields, which is a JSON, a venue name, lat and long, and venue ID. That's what I given here. Then followed by visibility. Visibility is a root field. We just say visibility and string type, response is string type, guess is a string type. And then you have a complex types called member, and then RSVP ID and the empty time, and the event is also complex type, which is a nested JSON. And kindly the group is a complex type. So we actually define our schema based on the JSON structure. So this, okay, just to go through this. Okay, so basically this is for specifying your venue object, venue field, which has the complex, not a complex, this is the inner JSON. Okay. Then we have a visibility field or column and response guest, and then we have another nested JSON, which is a member. Member has member ID, photo, and member name. And then you have a root element or root field, which is nothing but RSVP ID and empty time. Then you have a event as a nested JSON, which contains event name, event ID, time, and event URL. Then finally you have a group is again one more JSON field, it's a nested JSON, which has first field as a group topic, which is again a complex type, which is array type, which is array contains, which has a JSON format of URL key and a topic name. So if you just, I'll show you this as topic. Group topic is as array, which is a square bracket, and followed by it has also a set of JSON elements, which is keys, URL key and topic. So if you minimize this, you will have multiple things, right? So that's why we are actually defining that schema. Okay, that's how you need to define different fields based on what is the type of data is going to hold it. Okay, so other group, under group, what are the other columns are there, other fields are there? Group city, group country, group ID, group name, group latitude, and group URL name, state, which state this group is belong to, and latitude longitude and latitude of the group. Okay, all this are you are defining. Okay, so entire this schema is defined here. The schema name is basically meetup underscore RSVP underscore message underscore schema. This is very important. Okay, so now schema is ready based on our JSON structure. Now this is the initial data frame, right, which is taken from the stream data. So we are actually selecting the value column. We are casting it to string object or string data type, and we are also interested in another column called a timestamp column. Okay, just you are actually casting into timestamp field. So okay, so now, so once you have, then this data frame will have a value as a one column and times as a second column. So we are interested to value column where it actually has the JSON message. We want to parse it. So then you are saying data frame meetup RSVP underscore df underscore one dot select of from JSON. Okay, so this is a function used to parse your JSON message, and you pass the column which is a value column and provide a schema because it has to pass the JSON schema, right, or JSON message. Based on the schema only it can parse it. So you provide this sorry, excuse me, I have some throat problem, so that's why having struggling to prepare it. So basically now this will actually create the Spark streaming data. Okay, data frame which contains a value which is actually column is parsed using the JSON method and also JSON schema. You are actually giving the alias name as message details. The value column will be now converted into message detail, and the timestamp column again is same, just selecting it now. So this the JSON message is actually the message detail column will have the entire JSON message, right? So how we are actually pulling is we are saying JSON message detail dot star, so that all the column from it will come from the complex object. The we are trying to actually flatten the structure. Okay, so message detail dot star and timestamp, so that all the in this method you will see one message detail column which will have all the entire JSON message. Okay, so now as a individual array of all the columns. Now when you say star, it will become one columns. Like if you see the JSON structure, initially value is holding entire JSON message. Now when you say JSON detail star, when you become one column, visibility become one column, and response guest become one column, member has become one column, event become one column, and group become one column. So you will see this actually how many 9 columns total got here. So once you do this message detail dot star comma this one column, you just a star, this all this inner JSON will become 9 columns, and also additionally timestamp 10 columns you will see it actually. Okay, so if you display the schema for it. Okay, then once you have 9 columns, you can actually get the inner columns also by accessing the dot using the dot operator. Okay, so that's why I'm doing it in the second lane. So I am going to do the aggregation based on the some of the columns from the group field, because I want to aggregate basically at each interval. Okay, I'm going to set the trigger interval. Each interval, which group is actually getting more RSVP messages. Okay, that's what I'm going to do this aggregation. Okay, so first I want to get all these columns, basically group name, group country. So it is, you can access from the group at the field using the dot operator. Group name, group country, group state, group city, group latitude, longitude, group ID, group topics, and also I'm going to get the member name. All this column, I'm actually flattening and all the columns from the JSON structure. From the member you get the member name and the member ID and the member photo, other thing. the response column, guest column. From the venue, you get the venue name, longitude, latitude, venue ID. From the event field, you get all the fields. So basically, event name, event ID, and time and event URL. Okay, so everything you're just trying to make a flatter structure. Okay, so then I will actually display you this uh, schema so that you can see that. So finally, now in this step, what we are going to do is we are going to actually this is the raw data. Okay, the flattened raw data. The Meetup RSVP DF underscore 4 is the entire raw data. We are going to actually push it into the MongoDB collection. Okay, so to write the stream data frame into MongoDB, there is in out of box, like by default there is no option. So basically, Spark Structure Streaming provides API called for each batch. Okay, so what it does is from the stream API. Okay, from the stream API, you take the particular batch data for that particular batch. So you can actually do the operation. So basically, you iterate actually basically the batch API inside your stream API. Okay, so once you are able to access the batch data frame, then you can do the normal DF write operation. Okay, by providing the MongoDB connection URLs. Okay, so this is the MongoDB connection URL. So MongoDB :/ username colon password and at the rate host name colon MongoDB port number / MongoDB database name dot the collection name. So this is the URL you need to form. Okay, so let me print this URL also. So I just want to print and show you how this URL is formed. Okay, so it is this is a stream. This is the DF underscore RS Meetup underscore RSVP underscore DF 4 is a stream data frame. So I said write stream dot. I'm setting the trigger interval as 30 seconds. Okay, and the mode as update mode. uh, I will tell you why I'm doing the update mode. So basically, because I want to get the updated data and also the new data. Okay, so updated data and as well as the basically the appended data. Okay, so I want to get every batch. I don't want to get the entire data set. That will become duplicate records, right? So that's why I'm using the update mode. Okay, so I explained you what is update mode, what is complete mode, what is append mode in my another video. Please go through that video, you will get more understanding on it. So then as I told you, for each batch it will give the batch data frame and also the batch ID. So I'm actually adding the batch ID to the batch data frame. From that we derive there is batch data df underscore 1. We use the write operation. Write format is Mongo. Basically, because we are using MongoDB connector, this is the syntax to write into the MongoDB collection. Then provide the MongoDB URL, database name, collection name, dot save, and also so this. And then this for each dot start, so it will start writing the data into stream the data and write into MongoDB. That's what will happen. So once I run this program, it will just start consuming the message from Kafka topic, and it will write the raw data, which is it will actually parse the JSON message, flatten the JSON structure as a data frame, columns and rows, and it will write the data into MongoDB. So in the next video, I'll explain about what is the aggregation we are doing and how we are actually pushing the MySQL database. So let me run this program. We created this MongoDB collection. Now let me run this Kafka producer, which will start publishing the message. Okay, now we'll go on the I already stopped the Kafka, the command line consumer. Now the message is pushing to the Kafka topic. Now let's run the Spark streaming application. So either you can right click on the program and run it, or you can go to the run method and run this program. So basically when you run it, so it is going to compile your code, and it will going to build the jar and it will submit to the Spark cluster. So for now I am using the local mode running from the same PyCharm, sorry, IntelliJ IDE. Excuse me. So I'm going to run it from this IntelliJ IDE itself. So it is giving some warning for MySQL connector, because that this driver is, they're saying it is deprecated. Use different driver class. It's okay, it's warning. For now we can use it. Probably when you want to deploy it in the cluster, production cluster, then we can change it. We'll test it in the test environment with the a proper driver, and we'll test it out then before moving the production environment. Okay. Now it will wait for 30 seconds. I given the batch interval 30 seconds. Then it will try to. So in the first batch, I don't see any message. Okay, so we'll wait for the second batch. In 0th batch, we don't see any message. So let's see whether its messages are getting published. Yes, it's going on publishing the message. Okay, so let's wait here some more time. So second batch yet to come. You have to wait for that 30-second interval to finish. Okay, so once that is finished, then you will be. I'm actually, before writing into MongoDB, I'm printing the raw data for data and the console for us to debug and verify it before pushing into the MongoDB collection. Okay. Still it is. Okay, so now you see, so basically this is the the aggregated data. Okay, so I will explain you what aggregation we are doing in the next video. So basically if you come and see the MongoDB collection, I'll refresh it. It has actually pushed 97 documents. I'm opening the document, all the documents from this collection. Looks my system is getting some performance issue. Yes, 97 document is not a big data set. Still it is slow. Okay, so yeah, it showed. So basically I put it in the table view. The list view, you see this is a document. So I flattened the structure. So if you look out here, where is that? This is the nested JSON, right? I flatten it. Okay, using the schema, using the Spark structure streaming on the data frame operation we did, right? So using from JSON method, we just flatten parse the JSON object, and then we use the data frame operation to flatten it. Now you see this, all the columns are there, all the values are there. Now we are going to do some kind of aggregation in the next video and write the data into the MySQL database. I hope this video is helpful to you. Please subscribe to my channel DataMaking to get more technology videos. Please provide your feedback on this video. Thank you so much, friends.